Hi everybody. We're going to go through all of the problems in this Thermodynamics and Chemistry 1 worksheet one by one. I'll make a separate video for each one. This is the first one. Basically, this worksheet aims to give you a synopsis of the thermodynamics section in General Chemistry 1 as an introduction to thermodynamics. These topics are covered in much more detail in General Chemistry 2, but for now we're dealing with the idea of energy, heat, enthalpy, calorimetry, and sort of how we deal with these thermodynamic quantities. So the first problem on the worksheet describes that we have a calorimeter, and that calorimeter has water in it. When we dissolve in that water 23.6 grams of a salt called calcium chloride, the temperature rises from 25 degrees Celsius up to 38.7 degrees Celsius. They also give us the calorimeter constant for this process, which would involve the energy it takes to change the temperature of this particular calorimeter. So this device with that amount of water in it. I do want to point out here that the temperature has to be given in degrees Celsius or Kelvin units. The change in temperature would be the same for those two scales. If you're ever given a problem in degrees Fahrenheit, you must change that temperature, those temperatures, to degrees Celsius. All right, now what we know is that the energy of the reaction is going to be the same magnitude as the energy of the surroundings, or the calorimeter, but opposite in sign. And so given that, we can say the energy of this reaction is going to be the negative. I just circle my negative signs. It's a habit I picked up a long time ago, so I don't lose them. C cal times the change in temperature. And so we can go further to say Q of the reaction then is negative. C cal was given to us, 1258 joules per degree. And change in temperature is always final minus initial. And so we'd have our 38.7 minus 25 will give us 13.7 degrees. That's our change. Notice that if the process got colder, if this was a process where we dissolved some salt and it got colder, we would have a negative temperature in this bracket. But as it stands, we'll go through and do the math. So Q of the reaction is a negative 1258 times 13.7 gives us a negative 17,234.6. Our units here would be in the energy unit of joule. Okay. Now the problem actually says, what is the enthalpy change when 1.2 moles of calcium chloride dissolves in water? So what's the enthalpy change? Well, we have to remember here that enthalpy, or delta H, is the same as the energy change if that's done at constant pressure. Because at constant pressure, there's no work component. You can read up about that in the intro part of the chapter. But basically, delta H is the same as Q under these conditions where we're using a constant pressure calorimetry. And so the enthalpy change per 1.20 moles of calcium chloride. So, all right, I'm starting with 1.20 moles of calcium chloride. And if in doubt about where to start, write something down. How do I know where to go from here? Well, we just generated a conversion factor. We just said that, that's a terrible arrow, sorry, that every 23.6 grams of calcium chloride that I dissolve generates 17,234.6 joules of energy. That's a conversion factor now. And so the second part of the problem is really just a conversion problem. I ultimately have a conversion factor that's going to deal with grams compared to joules. And so in this first part, since I'm given moles to begin with, I just need to convert from moles to grams. And then I can convert from grams to energy. So what are my conversion factors? Well, formula weight for this first one, I'm going to go to the periodic table, add up a calcium and 2 chlorines, and I'm going to get 110.98 grams for every mole. And so in my first step, those cancel. And then in my second step, well, I've just figured this out, that I release 17,234.6 joules for every 23.6 grams. Now, usually, if you were to go to a handbook or to the Googles and look up the energy of dissolution or the enthalpy of dissolution, you're not going to find a number like so many joules per 23.6 grams, of course. You're going to find numbers that are either joules per gram, which is a very functional kind of a measure, or joules per mole. If we look at our units here, what we're actually going to get is just that unit of joules. So we're just getting a number here, enthalpy. It's the enthalpy per 1.20 moles in this case. All right, so when I do the math across and I say 1.20 moles times that 110.98 in the first bracket times 17,234.6 in the second bracket and divide by 23.6, I get a liberation of 97,255 and some decimal stuff over here, joules. I'm going to round this for significance because it's my final answer. We'll notice that in the beginning I started with 3 significant figures in all of my measurements, my 23.6 grams of mass, and both of my temperatures, 3 significant figures. And so I'll round this to 97,300 or 97.3 kilojoules. Okay. Now, if you were to go to, again, an engineering handbook or something and look up the heat of dissolution or the enthalpy of dissolution of calcium chloride, you're going to find that the reference value is about 80 kilojoules per mole. And if you do the math here, and we were to say my 97.3 that we just came up with, if I divide by the 1.2 that I started with, 1.2 moles I started with, so I get kilojoules per mole. This is really 81.1 kilojoules per mole. So it depends on the problem you're being asked. This problem said, what is the enthalpy change for 1.20 moles of dissolution? So the answer we got is fine. If it had asked us instead for the enthalpy change per mole, we would have done exactly the same math, except we would have started here with 1 mole. We would have gone through the same steps, but we would have gotten a number of 81 kilojoules. Okay, so it depends on the problem. You're going to see some problems that ask you for the enthalpy or the energy released or absorbed by a certain amount of material, like this one did. You're going to find some other problems that ask you for that same kind of a number per mole or per gram, in which case you would just start with the appropriate amount, 1 gram or 1 mole of that material. So that's an example of constant pressure calorimetry, where we're doing this, answering the question for enthalpy. Okay, so I'm going to do a separate video for each problem in this worksheet. So try them on your own, then check out my walkthroughs, and good luck with the rest of it.